So today we are going to be going over four different word problems, the four word problems that were in the thumbnail for compound interest. So being able to calculate the principal or the total amount, the interest rate, the time in years, etc. So let's begin. The first example says a principal of $7,500 is invested at 8% compounded annually. How much interest will be earned after 5 years? So for this one, what we actually have to do is we have to figure out the total amount that will be accrued after 5 years, and then we can subtract the original principal of $7,500 that we put in, and that is going to leave us with the amount of interest that was earned over that 5 years, because the amount that has accrued is just made up of two things. It's made up of the principal, so the original money we put in, and also the interest that we earned on that principal. So in this case, the principal is going to be $7,500. The interest rate is going to be 8%, and the time in years is 5 years. And then n is the number of compounding periods per year. Because this is compounded annually, compounded once per year, n is going to be 1 in this scenario. So therefore, the total amount accrued after 5 years would be equal to 7,500 times 1 plus 0.08 over 1 times, or to the power of 5 times 1. So if I grab a calculator, let's do that. 1.08 to the power of 5 times 7,500 gives us $11,019.96. Now the question asks how much interest was earned after these 5 years. So basically, the interest earned is going to be the total amount we have in the account minus the principal, right? Because the reality is $7,500 of this money isn't actually interest we earned. It's just money that we put in initially in this investment. However, anything extra above and beyond that $7,500 is money we earned through the interest rate. So therefore, this is going to be $11,019.96 minus 7,500, which is going to be $3,519.96. So therefore, the amount that was earned in interest in those 5 years was $3,519.96. All right, let's move on to the second one. The interest of capital invested at 10% quarterly for 8 years is $2,374. What was the original capital that was invested? All right, so first of all, in order to figure this out, let's start by just writing down what it is that we already know. So we already know that the interest in this case is equal to $2,374. We also know that it was invested at 10% compounded quarterly. So that means that the interest rate is going to be 10%. And then we also know it was compounded quarterly, so therefore n would be 4, because this occurs 4 times per year if it's quarterly. And then this happened for 8 years, so the time in years is going to be, the time in years is going to be 8. So we run into a little problem here, which is that there's two things that we don't know. We don't know A, which is the total amount, and we also don't know P. And the goal is to find the original capital invested. The goal is to find P. However, one thing we do know is that A, the total amount, is the same thing as the principal plus the interest, right? The total amount that will be accrued after a given amount of time is equal to the principal. So we still have the amount we originally invested in the first place, plus we have the interest. And so therefore, what we can do is we can just swap A for P plus I, and we do know the interest amount is $2,374. And with that, we are going to be able to solve this question. So therefore, on the left, I'm going to put P plus I, and I'm just going to right away sub in 2,374 for I is equal to P times 1 plus, oh, looks like the NT kind of got cut off here. My apologies. There should be that there. 1 plus R over N, so zero point 0.1 over 4 to the power of N times T, so 4 times 8, like that. And then we are going to have to figure this out. All right, so first thing I'm going to do here is I'm going to simplify the number that we're multiplying P by on the right here. So 0.1 divided by 4 plus 1 to the power of 8 times 4. Well, 4 times 8 is 32. So the power of 32, that gives me 2.2p. So 2.2p is equal to p plus 2,374. Now keep in mind p is the same as 1p, so if we subtract p from both sides, we get that 1.2p is equal to 2,374. So then if we take 2,374 and we divide that by 1.2, we get that p is equal to $1,978.33. Now, let's stop and think. Does this make sense that the original principal that we would have put in is $1,978.33? Well, honestly, yes, given that this was invested for 8 years and also invested at 10% a year, and compounded quarterly, so compound a little bit more often, it actually does make sense that around that time, we are going to experience more interest than principal, right? If we were to calculate the total amount, we would add this number, $1,978.33, to the interest. And, it would turn out that more of this money is actually interest than it is principal. However, this is how compounding works. This is not something you'd see in simple interest, but based on the high interest rate here and the number of years, this number actually is not too surprising to me. Even though this may seem very surprising that, how could we put in less money and have more money just be in interest? But this is about the crossover where that happens. All right, let's continue with the next problem. The interest on a principal of $5,639 at an interest rate of 5.5% annual interest, compounded monthly, is $2,385. How long was the principal invested for? Well, my guess, kind of long, but not necessarily that long, as it still hasn't surpassed the original principal yet. So, probably quite a few years, though, especially because 5.5% annual interest is not the highest rate necessarily. But, anyways, let's see what the actual answer is going to be. So, the principal here is going to be $5,639. The interest rate is 5.5%, so 0.055. The number of compounding periods, well, it's compounded monthly, and so therefore it would be 12 compounding periods. And then T, time in years, well, that is what we're trying to figure out. The exact question that we're being asked is how long was the principal invested for, so we don't know what T is. So we can plug in these values and figure this out. The only problem is you might also notice that A, the total amount, is not something they told us, but they did tell us that the interest we got in total during this time period, however long it was, that interest was $2,385. And we also know that the total amount is just the principal plus the interest, right? So we know that A is equal to P principal plus interest, P plus I. So therefore, we can just plug that in for A, we can sub that into our equation, and then solve for T, because at that point, T will be our only unknown, since we do know what the principal plus the interest is. So principal plus interest, which is our total amount, $5,639, plus the interest is $2,385. So therefore, the total amount is $8,024, right? Because $2,385 of that is the interest. The rest, the $5,639, is the principal. And that is equal to the principal, $5,639, times 1 plus r over n. So that's going to be 0.055 over 12 to the power of, actually, let's delete this, just a bit of that so we can see that a bit better, times to the power of n times t. So that's going to be 12t. So we're actually going to have to use some more advanced mathematical techniques. We're going to need to use logarithms in order to figure this out because our unknown is inside the power. Now, the other way we can do this, if we don't know how to use logarithms, is we could also just do trial and error and bank a pretty reasonable guess. But I would encourage doing logarithms if you know how to, since that will give you a direct answer and a very quick result, a much quicker result than doing guess and check. Okay, so now let's solve for t. First, I'm going to do 8,024 divided by 5,639, and that is going to give me about 1.42295 approximately. At this point, I'm going to be rounding to 5 decimal places just to try and avoid some rounding error, even though in the end we really just need 2 decimal places because this is dollars and cents, so we don't really need more in the end. And that's going to be equal to 1 plus all this stuff, which actually I'm going to figure out what that is. What is 0.055 divided by 12 and then plus 1? That is going to be 1.00458 approximately to the power of 12t. Okay, the next thing I'm going to do is I'm going to apply logarithm to both sides. So logarithm of 1.42295 is equal to the logarithm of 1.00458 to the power of 12t. Now, there's a rule with logarithms that when we have this in the power, we can put it out in the front, right? Normally, this isn't something we can do. We can't just change it to multiplication, but we can in this case. So we can simplify this to say that this is equal to logarithm 1.42295 is equal to 12t times the logarithm of 1.00458, and therefore 12t is equal to the logarithm of 1.42295 over the logarithm of 1.004583, like that. Okay, so let's find out what that is approximately. And then we're going to take it and we're going to divide it by 12 to get t. Okay, so I'm going to grab my calculator. We're going to need a calculator for this part and type in log 1.42295, then hit equals, divided by log 1.004583, hit equals. And then at this point, we're going to have about 77, actually you probably can't see that, about 77.1415, etc. So I'm going to divide by 12 to get t, and I get that t is 6.443 approximately. Now, actually, earlier I was saying, oh, we need 2 decimal places because it's dollars and cents. This actually is not. I'm just noticing now. This is time. So this is about 6.43 years. So close to 6.5 years, but not quite. So in terms of how long was the principal invested for, it was invested for 6.43 years approximately, which is a long time, but not like a super, super long time, if you know what I mean by that. Anywho, let's move on to the next one. All right, the interest on a capital of $3,000 was $2,475. It was compounded quarterly for 8 years. What was the annual interest rate? Okay. So let's write down all of the things we know. So the capital or principal is $3,000. So P is equal to $3,000. The interest rate is equal to Actually, that's what they're asking us. So actually, we don't know yet, which that's fine. We're just going to say question mark because that's what we're trying to figure out here. And then what about n? Number of compounding periods each year. Well, it's compounded quarterly, so that means there are 4 compounding periods a year. Then we have t time in years. That's going to be equal to 8. And then it says that the interest on the capital is 2,475. So that means the amount, which is going to be I plus P, is going to be $5,475 because we're just adding the principal and the interest up for this one. Okay, so therefore the amount is 5,000. The total amount is 5,475. That's equal to 3,000 times 1 plus the interest rate over n, which is 4 to the power of n times t. So that's going to be 4 times 8. So in my next step, I'm going to divide both sides by 3,000. So 5,475 divided by 3,000 is 1.825 is equal to 1 plus r over 4 to the power of 32. Okay, so now what I'm going to do on my calculator is I'm going to take the 32nd root of both sides. So let's do that. And according to my calculator, that is about 1.01897, rounding off there a little bit, is equal to 1 plus r over 4. All right, so next I'm going to subtract 1 from both sides to get 0.018977 is equal to r over 4. And then I can just multiply by 4 to get the rate. So times 4 gives me 0.0759. So we'll just round that up to about 6. So therefore the interest rate is 7.6% approximately. So the annual interest rate is about 7.6% rounded to 1 decimal place. All right, well, that is it for this video. Feel free to leave any questions you have down in the comment section, and we'll see you for the next one.